Okay, so let's take a look at part 2 for unit circle trig. What were the angles that we looked at yesterday? There were 4 of them that we found coordinates for. Yep, Paige.
0, 90, 180, 270.
Yeah, we found the coordinates for the 0, 90, 180, and 270. And all those coordinates were nice coordinates. Okay, they all had 1s, 0s, or negative 1s. Today we're going to look at how we can find the 6 trig functions, not just of those 4 angles, but of 30, 45, and 60. And what's nice is once we figure out how to find the 6 trig functions for these, to find the 6 trig functions of anything that's a multiple of these, which is what we're going to do tomorrow, it's basically what we're doing today, just thinking about it as mirror images. Okay, so it's once we know this, tomorrow's not too bad. Okay, so there's 2 special triangles we're going to look at to figure these out. One of the triangles we're going to look at is the 45, 45, 90. Okay, and the other one we'll look at in a little bit is the 30, 60, 90. Okay, those 2 triangles let you do pretty much everything you need for this part of unit circle trig. You probably learned about those 2 triangles in geometry. Okay, if you don't remember them, that's fine. Okay, there's nothing you need to remember. I'm going to show you everything right now. All right, so on your unit circle, which can somebody remind me again, what's the radius on the unit circle? 1. Okay, I've marked 45 degrees. That's 0. That's 90. So 45 degrees is exactly where between 0 and 90? Yeah, it's half. Okay, so the angle that we're trying to find the trig functions of, I'll just draw the angle right there. Okay, and I'll make these 2 sides red so you can see them. That's your angle. Okay, but anytime that you want to do unit circle trig, knowing the angle is not really the thing that's helpful. What do you need to know about this angle? Coordinate. You got to know its coordinate. Okay, so that's what we're going to figure out right now. Okay, and once we figure this out, we'll never have to figure it out again. Okay, we'll just memorize it. All right, so as I said before, we're going to make a triangle. And the way we're going to do it is draw a vertical line right there. Okay, so now I just made a triangle. What I've done is I just made a larger version of it so I can see it a little better on this side, over on this side. Now, I've labeled one side in this triangle as length 1. How come I know the hypotenuse in this triangle is 1 unit long? Yeah, because it's the radius of the unit circle. Okay, which I already know is 1 unit. Okay, these other 2 sides, I don't know them. But does anybody know if you compared the length of the bottom side to the height, how would they compare to each other? Look at what kind of triangle this is. Katrina, do you see what kind of triangle that is? Okay, it's a right triangle. Can we be even more specific than a right triangle? It's isosceles. So what does that mean?
It has 2 of the same lengths and 1 different.
Yeah, 2 sides are the same and 1 side is different. The 2 sides that are the same are across from the 2 angles that are the same. So the bottom side and the height are going to be exactly the same length. Okay, I don't know what to call them, because I don't know the number. So what could I call them for now? Why do you think I don't want to use A and B, based on what we just said about this triangle?
Because it would be better to use X and Y as the axis.
Okay, I'm not too concerned about like the letters you pick. You could use any letters you want, but I wouldn't use a different letter for the bottom and a different letter for the height. How come? they're the same, right? So I would use whatever letter you use for the base, use that letter for the height, because they are the same. So if you want to use x or y, the letter doesn't really matter. We'll just use x. Okay, so I don't know the bottom side, but whatever it is, it's the same as the height. Now I need to find x. If I can figure out what x is, it'll give me this length right here, which is this right here. That's how far I move from the origin to the right. And then if I can figure out this, it'll tell me how far I move from this point up to here. So in other words, if I figure out what x is, it tells me the coordinates of 45 degrees. How far right, how far up. Okay? And whatever it is, it's the same, both the x and the y coordinate. All right, any thoughts on how I can solve for x here? Any formulas I might already know, even if we didn't learn them in this class? Yeah, Dan? Yeah, we could use the Pythagorean Theorem, right? Anytime you have sides in a triangle and you have a right triangle, there's always a relationship between them, which is what Dan just said. So Dan, can you tell me what the Pythagorean Theorem would be using what I have up here?
X squared.
Yep. Okay, x squared plus x squared
Equals 1 squared.
equals 1 squared. Yep. And now I'll combine like terms, and then I'll solve for x. Skylar, what's x squared plus x squared?
X to the 4th.
Careful, if you multiplied them, that's what it would be.
2x squared.
2x squared. Okay, so add them up, 2x squared equals 1. Jake, what would be my next step to get x by itself?
Find the square root.
Not yet.
So then you divide by 2.
Right, divide by 2. So I get x squared equals a half. And now we can do what? Take the square root. Square root, square root. So x is the square root of a half. Okay, when you take the square root of a fraction, the way you do it is do the top and the bottom separate. Hey, Sam, what's the square root of 1?
1.
Yeah, just 1. Now the square root of 2, I can't really do anything with it. So I get 1 over the square root of 2. Katrina, what's wrong with that?
You can't have a square root of 1.
Right, so how do we fix it?
Just multiply the top and bottom by the square root of 2.
Yep. Multiply top and bottom by square root 2. And for my final answer, how about, Nick, what will I get when I do that out?
1.
Well, let's start in the top. What's 1 times the square root of 2?
Square root of
And in the bottom?
2.
2. That's the answer. Okay, square root of 2 over 2. That's what x equals. So now we know how long the bottom is. We know the height. So let's apply that here and see if we can get a coordinate for 45 degrees. John, how far to the right do I go?
Square root. 1 square root of 2.
Just square root of 2?
1 over square root of 2.
Yes, but once we fix it,
Square root of 2 over 2.
square root of 2 over 2. So yes, 1 over the square root of 2 is the answer. We just want to write that nicely. Okay, so we go to the right, square root of 2 over 2. And Shakira, how about how far up?
Square root of 2 over 2.
Same thing. That's your coordinate for 45 degrees. Okay, square root 2 over 2, comma, square root 2 over 2. Okay, now that we use the Pythagorean Theorem and we figured it out, we never have to figure that out again as long as we just memorize what that is. Okay, Any questions on that coordinate? All right, so let's try finding the 6 trig functions of 45 degrees. Right, so when I look at it, the first thing I look at is what information did they give me? Did they give me what I really need to do unit circle trig? How about Jesse? Do I have what I really need to do unit circle trig in this case? No, they didn't give me something very important. Who can tell me what didn't they give me that I need to either memorize or figure out somehow? Yeah? I have to have the coordinate for that angle. That's what I need to know. Okay, so Brian, do I know the coordinate for 45 degrees? Yes, I just figured that out. Okay. So what is the coordinate for 45 degrees? Square root 2 over 2, comma, square root 2 over 2. Does anybody remember seeing this coordinate yesterday? We already did this problem from here. Okay, if we go back to our notes. It says find the 6 trig functions of square root 2 over 2, comma, square root 2 over 2. The difference yesterday is you didn't know where this came from. Right? Now you would have to figure this coordinate out yourself first. Right? Or most likely just memorize it. Right? But just to practice, we'll go through them again. How about Kyle? What's the sine of 45? And did you pick the x or the y? The y. Good. Okay, Alyssa, the cosine of 45? Which one did you pick? Yep, that's the x. And lastly, my tangent. Okay, what do we get when we divide y by x? Yep, Shakira, 1. Okay, you're dividing two things that are the same. Everything cancels out and becomes 1. All right, cosecant. How about Nolan? Do you remember, even in general, what you do to the 3 on the left to get the 3 on the right? Yeah, just take each one and flip them. Okay, if you want to do the cotangent, you could do that one first. It's a quick one. When you flip 1, you get 1. Okay, Claire, what do I get when I flip the sign?
You get 2 over,
Yep, the thing,
yeah, 2.
square root.
Yeah.
And how do you fix that so we get the root in the top?
2 on top of
Okay, so when I do that out, I'm going to get 2 root 2 divided by 2. So the answer is just root 2. Okay, I think we've already gone through that one yesterday. Okay, and the last one, secant of 45 would be, John?
It would be square root of 2.
Also square root of 2. Since the sine and the cosine are the same, the secant and the cosecant are the same. And that's it. That's all 6 answers. Okay, any questions on finding the 6 trig functions for 45 degrees? Okay, so on a test, this would be 6 separate problems. Okay, what we just did in one example, that would be 6 problems. Let's say I asked you to find, let's just make up something, cosine of 405 degrees. Okay. What would be your first step to find the cosine of 405 degrees? Yeah. Yeah, subtract 360. Just 45. So if I ask you to find cosine of 405, all I'm really asking you for is the cosine of 45, which we just did. Okay? Same thing if I gave you something like this. If I said find the cosine of negative 315, you wouldn't subtract 360. This time you would add 360, and you'd realize it's exactly the same question. They could give it to you in radians. If they say find cosine pi over 4, and you're like, not sure what pi over 4 is, change pi over 4 to degrees, and you'll see that it's 45. Okay, so all the same things still apply. You might have to add 360, subtract 360, or change radians to degrees. Okay, so any questions on working with the 45, 45, 90 triangle? All right, so let's look at this one. Okay, the 30, 60, 90. Okay, so I'm starting off with our unit circle diagram. Okay, I've drawn 30 degrees about right here. Okay, it's a little bit less than 45. Okay, and what I'm going to do is make a triangle out of it by drawing a line to the origin and then perpendicular to the x-axis. There's my triangle. So the angle near the origin, that's your 30. Okay, you're starting at the x-axis, and it's going up 30 degrees. So that's where I get the 30. But how come I know the top angle has to be 60?
Should be your angles of triangle have to add up to 180.
Yeah, all the angles inside the triangle add up to 180. So I know if I made a right angle in the corner, that's 90. That angle is 30. That's 120. So 60 degrees is what's left. Okay, and I'm going to draw the same triangle off to the side a little bigger. Okay. Is there any side in this triangle that I already know? I actually know a number for how long it is. Yeah. Yeah, how long is the hypotenuse? Yeah, the hypotenuse is 1 unit long because it's the radius in this circle, which is a unit circle. All right. What kind of triangle do I have this time? It's a right triangle, but I mean, is it isosceles? What is it this time? Brian?
Scaling,
Scalene. What does that mean?
all the sides different.
All the sides are different. Okay, so we can't do the same trick we did last time. I can't just label them with 2 letters that are the same, because they're not the same. Okay? This side is the shorter side, that side is the longer side. Okay, I have to figure out what those 2 things are. Okay, and to do this, I'm going to draw something up here. Okay, anybody have any thoughts? This is a little tricky to figure out, but it's a visual trick I'm going to do. Anybody have any thoughts what I can do with this triangle right here to somehow start to figure out how long these other sides are? I'll give you a hint. It involves making a copy of it and then doing something with that. Yeah? So I'm going to let's just group all that together. All right, so I'm going to make a copy. And now what did you say? Oh, make a rectangle out of it? All right, so to do that, I'd have to kind of flip that triangle around a little bit. I like the idea of flipping it, but instead of making a rectangle, let's do something like this. All right. So what can you tell me about the triangle that I just created? Yeah? Hey, I just created an equilateral triangle. 60, 60, 60. Okay, what do I know about equilateral triangles, Katrina? All the angles are the same. Anything else? In this case, I'm not as interested in angles. I'm interested in something else.
All the sides.
All the sides are the same. Yeah, that's really important. Okay, all the sides are the same. So this side is 1. This side is 1. This side is 1. So now that I know that, does anybody see what I can figure out? Yeah?
If you divide that by 2, you can figure out that one side.
Right, these two triangles are congruent because they're just reflections of each other. If this entire side is 1, and if it's made up of 2 congruent segments, each segment would have to be how long? A half. Now I know this side is a half. I don't need that bottom triangle anymore. Okay. In fact, just to make it less confusing, I'm going to get rid of it. So now I know 2 out of 3 of the sides. Now I can call the last side x, and I can solve this just like I did the last one. Because I only have one thing I don't know. All right, so Shannon, what's that theorem that we use again for the sides in a right triangle?
The Pythagorean theorem.
Yep, Pythagorean theorem. And can you plug in what I have into that theorem and tell me what my equation would be?
1 squared,
Yep.
1 half squared, would equal 1 half squared minus squared.
Half squared plus what else?
X squared.
Yep, perfect. Okay, that's my equation. And now I just need to solve it. So I'm just going to move everything up a little bit. Okay, so I get 1 squared is 1. What's 1/2 squared? How much is that? A quarter. Half of a half is a quarter. Plus x squared. Okay, bring that quarter to the other side. So subtract it. Okay, and what's 1 minus 1/4? 3/4. So I have 3/4 on the left, x squared on the right, and my last step. Yep, take the square root. So x equals square root of 3 over square root of 4. And one of those I can simplify nicely, and it's going to save me from having to do extra work. Skylar, can I simplify my numerator or denominator?
Denominator.
Yeah, what's the denominator simplify to?
2.
Yeah, we just get 2. So I get x equals square root of 3 over 2. Okay, now I know the length of this bottom side. Square root of 3 over 2. And now I know how far to move in each direction. Okay, so I should be able to now figure out my coordinate for 30 degrees. Hey, anyone think they could tell me the coordinate for 30 degrees? Yeah, Kyle?
Square root of 3 over 2 and 1/2.
Yep, square root of 3 over 2. That's the length of the bottom. That's how far you move to the right. And then how far up? You go 1/2. Okay, so that's the coordinates for 30. And now I also want to know the coordinates for 60. Any thoughts about how I can maybe use what I already have to find the coordinates for the 60? Here would be my triangle for the 60. Yeah?
Would it be the opposite?
Yeah. Okay, what happens with the 60 degree, where I've put it this time, now this angle up at the top, okay, becomes 30. Okay, that becomes the small angle. And this angle at the bottom that I just highlighted, that becomes the 60. So all you're really doing is taking this triangle and standing it up. So since the 30 and the 60 switch places, so do the x and the y. Okay, so the coordinate for 60 is just 1/2, and then up square root 3 over 2. Okay, so same two numbers, just switch them. Okay, and the way you can remember which one goes where, 30 is the smallest angle, 1/2 is the smallest side. Smallest angle is always across from the smallest side. Okay, as a decimal, square root 3 over 2, that's like 0.86 or something. 1/2 is smaller, it's 0.5. Okay, so these are the two coordinates that you want to make sure you memorize for the 30 and the 60. Okay, and as we did some problems yesterday, I think we had some problems where square root 3 might have popped up a little bit. Yeah, the first one we did. Okay, there was a negative here. We don't have any negatives today. We'll see that tomorrow. Okay, but square root 3 pops up a lot, and so does square root 2. Okay, depending on what kind of triangle you're working with. Okay, does everybody have those two coordinates written down? All right. So, let's see if we can find the 6 trig functions for pi over 6. Okay, Rebecca, as you take a look at that, what do you think the first thing is you might want to do?
Take into degrees.
Yeah, I would change to degrees. And how do you do that?
Multiplied by 180 over
180 over
5.
pi. All right, so Katie, what's the angle that I'm working with here in degrees?
30.
30. Okay, all I'm really asking you for is the 6 trig functions of 30 degrees. Okay, Brianna, now that I know the angle is 30 degrees, what's the next thing that I really need before I can start doing all this? Yeah, I need the coordinate. Now, if you get confused, okay, if you can't remember which one is the 1/2 and which one is the root 3 over 2, just draw a picture. Okay, 30 degrees is about right there. Make my triangle. In that triangle, which side is the short side? The base or the height? Yeah, the height is the short side. And I said to you the smallest side is always what number? How long is the small side? 1/2. And that means the long side is root 3 over 2. You just have to remember those two numbers, 1/2 and root 3 over 2. Draw your picture and always make the small side 1/2. Make the long side root 3 over 2. So my x is root 3 over 2. My y is 1/2. Okay, that's usually how I do it most times. I just make a picture rather than try to memorize everything. All right, so now let's see if we can find our trig functions. How about Jared? What would the sign be? Yep, it's the y value, which is 1/2. Okay, John, how about my cosine?
It'll be X value, which is square root of 3 over 2.
Yep, square root of 3 over 2. And Dan, how about my tangent?
square root of 3 over 2 over a half.
Careful, that's the cotangent. So how would you do it for a tangent?
So it would be a half over square root of 3 over 2.
Yeah, just imagine putting a division sign in right there. Okay, and that's when you divide those two things, that's your tangent. 1/2 divided by 3 over 2. Jasenia, what's going to cancel out here?
The denominators.
Yep, denominators are gone, and I'm left with 1 over the square root of 3, which when I fix it is the same as what? Square root 3 over 3. Okay, so for this one, I'm going to write square root 3 over 3. Okay, let's look at the cotangent. Should I flip this, or should I flip the one that's on the right? Yeah, the same thing, because they're equal, but which one would be faster? Yep, flip the one on the left because the root's in the bottom, and it'll go to the top. So, Katie, what would be my cotangent? Square root of 3. Okay, how about my secant? Karen, how do I do that one? And which one are you flipping? Sorry, which one? 1/2. Oh, sorry, I meant, did I say cosecant? I thought I said secant, but yeah, you're right. Cosecant would be 2. How about the secant? Which one do you flip for that? Yep, flip the cosine. So you get 2 over 3. And Alyssa, what will I get once I fix that?
You get 2 square root of 3.
Yep, perfect. Hey, that's just 6 trig functions for 30 degrees. Okay, same idea we did with the other ones. They could give you an angle like, say, 5 to 6 trig functions of 390. First thing you want to do, subtract 360, make it smaller, and you'll see it's the same question. Okay, so they could give you angles bigger than 360, smaller, or they could give you something in radians like they do. Okay, any questions on that one? All right, so the last one, why don't you try that? Okay, see if you can find the 6 trig functions of 60. Okay, if you get stuck, draw a picture, draw your triangle, and then figure out your coordinates from your picture. Okay, so as we went through it, or as I just summarized, what's the coordinate for 60 degrees?
1/2 square root of 3 over 2.
Good. 1/2 square root of 3 over 2. Okay. On the test, there'll be 2 parts to most problems. First thing I'll ask you for is, what is the coordinate? Okay, so John just answered the first part. Okay, the second thing I'll ask for is one of these 6 per problem. Okay, so I'll ask you for the coordinate, and then I'll ask you for one of the 6 things that I'm circling. All right, and that's how the homework will be set up tonight. It's a worksheet. It asks for the coordinate and then the answer to one of these 6. You don't have to do all 6 in every problem in the homework tonight. Okay, so let's start with sine. Okay, Nick, what's my sine?
Square root of 3 over 2.
Yep. Okay, Nolan, my cosine?
1 over 2.
1 over 2. Katrina, how about my tangent?
Square root of 3.
Yep, just divide them and the 2's cancel. Okay, Paige, how about cosecant of 60? 2 square root of 3 over 3. The secant, that one's going to be quick. Flip it and we get 2. And this one wasn't a fraction, so if you want to make it 1 before you flip it, just put it over 1. And how about Brian? What's cotangent 60? Yep. Square root of 3 over 3. Okay. Compare that to the answers we just got for the 6 trig functions for sine. Okay. What do you notice about the 6 answers I got for sine and the 6 answers for cosine? I'm sorry, the 6 answers for the 60 and the 6 answers for the 30-degree angle.
They're the same, but what?
Yeah, they're all the same numbers, just in different spots. Okay. Notice the sine and cosine switch places. The secant and cosecant switch places. And the tangent and cotangent switched places. Okay. But they're all the same answers. Okay, that's exactly what should have happened. Questions on finding the 6 trig functions for 60 degrees? All right. So the homework tonight will be a worksheet I'll pass out in a second, and these 5 extra problems. Okay, so these 5, you need to write these down. Okay, so for every problem, okay, I'll just show you one from the worksheet. Okay, this is the first question. It asks you 2 things. Tell me the coordinate. Okay, so first thing I want to know is the coordinate. And then the next thing I want to know is what's the actual answer when you take the sine of 45. Okay, so I tried to set this up just like the test. Okay, so tomorrow we'll finish unit circle trig. I think we're pretty much on track to do that, which means Thursday we'll be able to review first half of class. We'll start the test on Thursday, and we'll finish it on the half day Friday.